Okay, so first thing I want to do is draw a free body diagram. And the rotation is happening in this plane. And so you can, there's a number of different ways to draw the free body diagram. And so I'm gonna draw it a certain way, and then I'm going to try to explain some of the gotchas. Okay? But I'm going to draw the free body diagram like this. I've got weight going down, and then I've got the normal force of the table pushing up on the puck, and then I've got a tension in the string that's pulling, and if the object is located right here, okay, then the tension is pulling that way in this direction. Okay, so I'm going to draw that like that. Okay, there's my tension. And the thing is, you can have the tension both to the left or to the right. You just have to recognize that you're going to have a negative or positive sign, and you're going to need to remember that when you put the values in. Okay, so our givens are the mass of the puck, which is equal to 0.177 kilograms, and the radius, which is 1.6 meters. Also, there's a mass down here that's pulling, just like in the lab. Remember, we had a 0.2 kilogram mass pulling. Well, now we've got this block that's pulling, and it is going to be, I'm going to call it the mass of the tension, and it's 0.47 kilograms. And then we're also given that the acceleration due to gravity, g, is 9.8 meters per second squared. Okay, so the first part, it says, what is the tension in the string? And these questions are kind of leading. They're leading you to the final answer, which is the speed of the puck. Okay, so our first unknown is going to be tension. Our second unknown, what is the horizontal force acting on the puck? And then, and that's going to be, we have it depicted as tension. And then the fourth unknown is what is the speed of the puck, and that is the tangential velocity. Okay. So our equation, well, we know that according to Newton's second law, sum of the forces is equal to mass times acceleration. And we know in this case, for this puck to move in uniform circular motion, the force needs to be a center-seeking force. It needs to be a centripetal force, and it has to equal the net force. In other words, all the forces added up together have to equal the centripetal force. So I'm going to also write that sigma F is going to equal Fc, and we know that that's equal to mvt squared divided by r. Now sometimes you'll see it as just v. There's a lot of different subscripts people use. Okay, so we're going to start out, and we're going to sum our forces. Okay, now I'm going to start out in the x or in the y dimension, because I'm really thinking about what is the tension, and the tension in this case is provided by this mass pulling down. Okay, so I'm going to say that the sum of the forces in the y direction are going to be equal to, normally they're equal to mass times acceleration in the y direction, but based on what you know about this problem, is this mass moving down or up, or is it staying in the same place? So there is no relative motion of the mass. Therefore, the mass is not accelerating. Therefore, the sum of our forces in the y direction equal 0. This is the y direction here. Okay, so sum of the forces in the y direction are 0. So it's pretty much the same as we've been doing, right? Now, we know that there are two forces. There's tension and there is the weight of this block that has a mass of 0.47 kilograms. And those are the two forces that act in the y direction on this weight here. So we know that the tension is up with respect to this mass, and that weight, the force of gravity, is pulling down on the mass. So tension minus weight equals 0. Now I've skipped a little bit, right? Because remember, I've been finding the components of the forces, right? But I skipped it because you know that the tension in this part of the wire, or the cable, is straight up. So it's purely in the positive y direction. And you know that gravity is purely in the negative y direction. So I just skipped all the sine and cosine business, and I went right to tension minus weight equals 0. And all this does is tell us that the tension is equal to the weight. That's all it does. It just mathematically allows us to prove that instead of just guessing at it. So what is the weight? Well, it's the mass times gravity, yes. So we've got 0.47 kilograms times 9.8 meters per second squared.